Hello everyone, I hope you are well and welcome back to another 4D Systems project video. In this video, I'll be showing you how I made this car speedometer on a 4D Systems ulcd 70DT display using the Workshop 4 IDE. As usual, I'll be taking you through the entire process, starting off in Photoshop to design the UI and then programming in Workshop 4. Let's get started. So just like the other project videos, I'm going to be starting off here in Photoshop. I'm just going to quickly take you through all the different graphics that are going to be used in this program. Now, if you watch the motorcycle or the bike speedometer project videos, you should be able to kind of figure out the workflow now for designing these speedometer interfaces. I would definitely recommend that you watch those as well as our other project videos if you are interested to see some similar projects. As I mentioned in those tutorials, these UI graphics will all be broken into layers in a way that is applicable and suitable for the Workshop 4 programming environment. Starting off with the background of the display. This is simply the parts of the UI that are going to remain unchanged throughout the program, and so we can export them all as one background layer. You can see here that for this project, the background consists of these graphics on the screen, as well as some labels such as the trip and total. So that is pretty simple. Moving on to the two main gauges I have here to show RPM and kilometers per hour. These are going to be rebuilt within Workshop 4 using the Smart Gauge widget. In this folder I have the dial graphic, which is the circle with the numbers. I have the needle graphic, and I have the shadow for the needle as well. It is also the same for the gauge on the left, except the label in the middle is different. So in Workshop 4, the needle will be animated to be rotating like this within the degree range here. We then have these bars down the bottom which are indicating power and battery. These will also be made using smart widgets, however instead of rotating like these gauges here, they will be moving along the x-axis to show the meter being filled up. The numbers above the two gauges will also be moving up and down in relation to the meter. Okay, then we have the turn signals which have the two states, those being on and off of course, which you can see as I switch between the layers here. Really simple, we will just be switching between these two states for both. And the final part of this UI will be the gear indicators. This graphic also has separate on states for each of the gears to show when any one of them has been switched to or turned on. And that is pretty much it for the design of this UI. Now I'll go ahead and export all of the necessary graphics into a folder so we can start programming in Workshop. Now that everything has been exported, something important to remember is, where applicable, your graphics should be exported in the individual layers that I just showed you. That way you can have full control over all of the individual components of each graphic. So for example, this gauge, I'm only going to want to animate the needle and its shadow. I don't want the perimeter circle or the numbers behind to rotate with it, so I'd want that to be a separate base layer. Same thing with the meters at the bottom. I obviously don't want all of these elements moving together. Now that we're done with Photoshop, we can move into Workshop 4 and start the project. The display that I'm using is a Gen 4 ulcd 70DT, so I will use the drop-down menu to choose Diablo 16 and find my display, and I'll be working in the Visi environment. I'm going to first import all of the UI elements until I match the Photoshop file, and then from there I will go ahead and code everything as the final step. Just like the other projects, I'm going to load in the background image onto the form. To do this, I'm going to go to the Object Inspector here on the right side, and I'm going to go down and select the image option. Once I select this option, the File Explorer will pop up and allow me to choose the image that I exported to be used as my background. And now it will pop up here in Workshop. I don't want to make any changes to it, so I'll just press OK. And then after that, I'll go down to these options again and change the background type from color to image. This will now allow the background image to be displayed. Let's continue and start building the other parts of the UI. Next are the power and battery meters at the bottom of the screen. To build these, I'm going to need a smart gauge. I'm going to navigate to the widgets menu, go over to the gauges tab, and drag in a smart gauge widget. It's empty right now, so I'm going to have to configure it using the UI elements. With the smart gauge selected, choosing the config option here in the object inspector will open up the smart widgets editor. Now the first thing I need to do is import the base image of the gauge, which in this case is the numbers and circle that I said were going to remain static in the program. This layer I am not going to be able to manipulate and will always remain the base layer of the widget. After that's imported, I'm going to scale it down so it is fitting on the screen properly and at the right size. Next, on layer 1, I am going to import the color fill that I have named yellow bar. This is the layer that will be moving and indicate the amount that this bar has been filled. So on layer 1, I'll choose the 3 dots, import that image and enable the layer so we can see it. And I'm going to give it 100 frames. I'll adjust its reference point so it is aligned with the base image. And because I do not want this graphic to be moving on the Y value, the min and max Y value here should match the reference point so it is locked on the Y axis and unable to move. However, on the X axis, we basically want it to move from the start to the end of the bar. So I'll adjust the min and max X values according to that. While I'm on this layer, I'm also going to enable the numeric part option. This will turn on a numeric indicator that is linked to this layer and its frames, meaning depending on the frame that this bar is at, the corresponding number will be displayed at the same time. I want this number to be displayed as 1 digit, a decimal place, and then 2 more digits. So I'll change this format option to 0.00. And then I'll just adjust its font, size, and color. Now that I'm happy with how this is looking, the final thing to do is add in the graphic labeled back color, which is just a gray color to fill the portion of the bar that is in its off or unfilled state. So again, I'll import the image, enable the layer, and align it with the rest of the graphics. This one does not need to be animated, so I'll leave it as is. And there you go, the first gauge or meter of the program is done. This is a great example of how the Smart Widgets editor allows you to have complete freedom and control when making and using your own custom assets. It doesn't necessarily have to be a round gauge. So now, instead of repeating all of those steps for the meter that goes on the right side, I'm just going to copy and paste this bar and place it over on the right. However, on this one, I'm instead going to give the meter 1000 frames and change the numeric part format to 0.0. Those are now done, and we can move on to the large gauge graphics that take up most of the middle portion of the screen. This is a similar process to what we just did, except instead of moving left and right, the needle will be rotating. I'll import the base image and scale it down till I'm happy. On layer 1, I'll import the needle graphic, enable the layer, and set 300 frames. I'll set its reference X and Y values all to the center. Now I just have to set the rotation values, and this layer is done. When I scroll through the frames, you can see that the needle is working as expected. Same as before, I'll also enable the numeric part option and just adjust the way that it looks. The last layer for this gauge here is the shadow underneath the needle. The settings for the shadow are essentially all the same as layer 1, 300 frames and rotation values. After those are done, I'll press the link groups 1 and 2, and I also want this layer to be below the face image. Now this gauge is also complete. I just need to transfer this over to the right side as well, and I'll replace the base image so I don't have to redo all of the settings again. Okay, onto the gears in the middle. This is very simple. I'm going to go to the widgets menu, choose the system media tab, and then drag in user images. If I choose the image option in the object inspector, I can import all of my graphics that I showed you earlier in the Photoshop file. I'll be coding these later to switch between the various images. The very last part of this program are the left and right indicators. These are exactly the same as the gears, just using user images that the program will be cycling through. So after they are imported, I just have to press OK and place them where I want. Now that all of the design and setup for the program is done, the very last thing we need to do is code the display. I'll go through the code quickly to show you how the program works. In the setup, we are mounting the SD card, loading the project's graphics, setting the display orientation to landscape, and drawing the main form. The program then enters an infinite loop. Inside this loop, it runs a frame counter up to 1100 and uses that value to cycle through different widgets on the form. For example, the RPM cycles through frames 0 to 100 and the kilometers cycled through 0 to 300. The user images also toggle between their frames as well. And that is the code finished. From here, I'm just going to double check my project settings, and then I can compile and upload the program. As this program has a lot of frames on the gauges and user images, flashing it directly to the display might take a bit longer than normal. It will still work, of course. However, I would personally recommend that when you have a lot of assets, sometimes you will find it easier to upload the program to your SD card directly and then mount the SD card onto your display afterwards. That is all for this video. I hope you enjoyed. If you would like to take a look at the Gen 4 ulcd series used in this video, please head over to our website 4dsystems.com.au. If you have any other questions or need help with anything 4D related, please head over to the 4D Systems Resource Center. Thank you for watching and see you next time.